All right, so welcome. So length of a line segment. If you want to know how long a line is from one point to another, then of course you can take out a measuring tape and try to measure it out. Now, in high school, you often get stuck with this problem where you have a line segment and it's on a Cartesian plane or the x and y axes, and then they ask you, how long this thing is. So you can actually kind of think back of what you have learned in the past and project things out and find out how long a line segment actually is by just simply using triangles. So here is a line segment, and I'm going to show you, how you can go about finding this length of a line. So imagine, if you have a line, you of course can create a triangle, and in particular a right angle triangle. Okay, so by simply kind of extending this out, so I'm going to just show you, and you can do this with any line segment and create these nice triangles for yourself. So what do we remember, from kind of elementary school in grade 9, is that if you have a right angle triangle, so in here we do have a right angle triangle, so here is our right angle, then the lengths of the triangles, okay, so of the sides, are basically related. And how are they related? Well, they're related through the Pythagorean Theorem, and in this case we have the actual hypotenuse of this triangle that we're interested in measuring its length. And so let me just label this. So if you had, so this is kind of a deja vu, so this is A, B, and this is side C, we should remember that the hypotenuse, so C squared, is equal to A squared plus B squared. Now it doesn't matter which one is A, which one is B per se. And then of course we can find out what the hypotenuse is by just simply taking the square root of A squared plus B squared. So people remember that. So if we knew what the sides were, we could figure out exactly how long that line segment is. But we know what the sides are, because if you have a line segment on a Cartesian plane, well, then the points you can find out. So in this case, so I'm going to, let's just imagine, okay, so let's say this is point number 1, and then this is point number 2 right here. So, well, we have those points. So we actually know what A is, and we actually know what B is. So if I, for instance, take A, so if I take from this point to this point, all right, so if I'm going in this direction, okay, so how long is this A? Well, I know exactly how long it is. So notice that this is just going along the y axis. So this is basically nothing else but, how far does this rise, or how far does it fall if you're going in the opposite direction. And for that reason, okay, so I'm going to just write here. Okay, so in general, what you would have is you would just simply take your, y2 point and then minus your y1 point, and you know exactly how long that rise is, right? So that's what we would have there. And then we can find out what B is, and by exactly the same process. So in terms of B, all right, so we can kind of go, doesn't matter in which direction we're going. So let's say if I'm going in this direction right there, all right, so this is my B, and for my B, this is just my run. And now my run, well, my run is nothing else but simply, again, x2 minus x1. And that's what you would have there. And once you find out what that is, now it doesn't matter if the rise or run is positive or negative for us, because of the fact that, as you can see, when we're trying to find the line segment, the hypotenuse, we're going to be squaring them anyways. So notice we're going to be squaring these. So if they're positive or negative and you square them, well, then the answer is going to be positive, and we know exactly how long something is. So let's do that. All right, so for this particular line segment, so what we have, if I take my y2 minus y1, so in this case what I have is basically 5 minus, and the y1 is 1, so this is 5 minus 1, so it's equal to 4. And that shouldn't surprise you, well, because we're going upwards, 4. Okay, so notice 1 up, 2, 3, and 4, just the way that it's labeled there. So that's what we have there. And then my run, so right here, so in this case, okay, so what we have is x2, so this is minus 4, and then minus, and it will be 3, okay, on the other side there. So this is going to be negative 7. Now, of course, the run or the length of a side can't be negative, but as I said, that doesn't matter. You just simply take the kind of absolute value of this, and you know exactly, okay, so absolute value of that, and you know that the actual length, okay, so that b is 7, and you can see that 1, 2, 3, 4, 5, 6, 7. All right, and because you're going to be plugging it in, so in here, and you're squaring it, okay, then it doesn't matter. You can keep it negative, and you can find out exactly how long your line segment is. So if I would do this, so you know, obviously I'm going to get 4 squared plus, let's keep it negative 7 squared. All right, and I'm going to take the square root. And once you do that, you can find out how long your line segment is. Now, it's not always kind of this convenient where the points are so nice, like, you know, 3 and 1 and then negative 4 and 5. They can be fractions, they can be decimals, it doesn't matter. So in general, okay, so when you are trying to find out what the hypotenuse is simply, okay, if you want to know what the length of the line segment is, you can call it whatever you like, so I'll just keep it at C. So you will notice that this is simply, okay, so you have your x2 minus your x1, this is squared, because that is your run, squared, plus your rise, which is y2 minus y1, and this will be squared, and that's your actual equation. And often in high school you're going to see this, and people just kind of memorize this, but they forget what it actually means. So you don't really have to memorize anything here. You just simply realize that you're creating a right angle triangle, and then you're just using the Pythagorean theorem to find out, you know, how long a line segment is, and that's about it. All right, so I hope that you find this useful. You can of course practice it on any line segments that you like, but it's a neat thing to kind of keep in mind. And if you really want, I mean, you can try to memorize, but memorizing is kind of useless. It's better to know the intuition behind these problems. All right, so thanks for watching. All right, we'll see you in a future video. Bye.